So my name is Pierre-Luc Vaudry, and I'm a researcher at Zero Spam. And I'm going to talk about the first stage of our research project at Zero Spam, which is on machine learning for spam detection, but the first stage is data collection. First, spam detection is often cited in machine learning textbooks as a very simple example of binary classification of supervised learning. But is it that simple? In fact, email evolves over time, so spam evolves over time, and legitimate mail also. And not only this, but spammers will change their techniques not only in time, but also in response to how we improve our spam filtering. Here's an example of some kind of spam that we need to filter. So those are examples of fake invoice emails. And to detect them, we have to see the difference between those fake invoice emails and real invoice emails. And also, we have to see what are the similarities between those two, because they are part of the same campaign, spam campaign. The first one reads the invoice with an invoice number. Dear, sending you your invoice dated 28 September 17. Please call me with any questions or concerns with phone number. Get an invoice with a link. Looking forward, jane@company.ca. And the second one has a slightly different subject line and wording. It reads payment number issue. Current reach over your phone number for some reason. Need to know the status of this invoice. Please reply as soon as possible. With again a link. And I've been told by our experts that one way to see the similarities between those two emails is by analyzing regularities in the links that are given. And there are other factors also that come to bear on the verdict. But basically, we use a combination of handcrafted rules and machine learning to detect the spam. And what we want to do is rely less and less on handcrafted rules and more on machine learning. So as I said, this talk is about data collection mainly. Before, we had only a corpus of about 20,000 emails to work on, and that's not a lot in machine learning. So what we lacked was the proper software to collect data from our infrastructure, and also the ideas that what to collect. So at Zero Spam, we offer a cloud spam filtering solution. That means that we have inbound email that comes from the internet through our filtering system, which has two main steps: envelope filtering and content filtering, and to our clients. And we also filter outbound mail coming from our clients, going to our infrastructure, and then to the internet. Here in envelope filtering, what you do, this occurs at the very first step of the SMTP transaction. So we only have the from and to address, and the domain that is from which the spam is claimed to come from. But we can do several checks at that point, but the two that are most relevant to this talk are the IP blacklists and domain blacklists, because that could be a way that we thought about of getting spam sources. After that comes content filtering. Then we download the actual content of the email, so we get the headers, the text, and the attachments. And we can do machine learning on the text. That's what we do right now. And we have encrypted rules that contain, among other things, regular expressions, but also other kinds of rules. We have client-specific blacklists and whitelists, antiviruses, and attachment analysis. And what we would like to do is, in our data collection, collect not only the email content, but also metadata from all those checks that are done, antiviruses, handcrafted rules, to tap in the knowledge that is there for our machine learning. And the two sources that we have selected for spam and legitimate mail. For spam, it's we take our mail from honeypots. So honeypots are services that provide spam by putting email addresses on web pages where only spammer software can find them. And for legitimate mail, we take mail from our outbound filtering service, so from our clients, because we're pretty sure that almost all of it, although we filter it, almost all of it is legitimate mail. But we cannot store or read our client legitimate mail, so we have to maintain confidentiality. That's the first challenge. Another challenge is that we don't want our data collection to impact on delivery of the email. So we have to have a software that is reliable in that respect. So I'm going to talk about those two challenges in the next slides. To maintain confidentiality, what we do is that right now our machine learning is based on character n-grams. So those are groups of characters. Here we have groups of 4 characters. We extract those n-grams from the email text, and then we don't keep the text. We don't store it. So that's the first step. And then what do we do with the character n-grams? We store it in 2 separate files. So the first is a vocabulary that is encrypted or hashed, and that contains mapping from character n-grams to indices. And we store separately in the dataset file for each email that was collected, vocabulary indices and n-gram counts. In the future, so this is useful for offline learning, where we can reproduce results more easily. We can do several experiments on the same data. But the downside is that we only have access to n-grams this way. So if we want more advanced deep learning algorithms, what we need to do is do online learning. And this has the advantage that we only store the model parameters that are learned online from the data. So that's even better for confidentiality. But we cannot reproduce the same the results with the same data again and again. To solve the reliability challenge, what we did was, in parallel to the sending of the emails from the content filtering step to the internet, we put them in a sending queue that's dedicated to data collection, and we use a sampling rate to only take a subsample of those emails. And once you're in the sending queue, if there's a problem with that data collection, the sending queue will increase in size, and after a certain size, we just stop sending email to the data collection until it's ready again to collect data. And so it doesn't impact the filtering chain. The last challenge I want to talk about is the performance metric. So in spam filtering, it's not that appropriate to use regular metrics that come from information retrieval, like precision, recall, and F1. First, because we have to consider what we call true negatives, so correctly delivered legitimate mail. Those are not considered with the measure that I cited. And also, we want to take into account that for our clients, most of the time, discarded legitimate mail are more costly than undetected spam. So false positive are more costly than false negatives, and we want to reflect that in our metric. So we use the expected cost So the formula reads the proportion of positive, so proportion of spam in our real data, times the false negative rate times the cost of false negatives, that is the cost of the detected spam, plus the proportion of legitimate mail times the false positive rate times the cost of false positives. And what we do is that, like we saw earlier in the ROC curves in the last presentation, we find a point on this curve that corresponds to the classification threshold that optimizes the expected cost, and we calculate the classifiers based on the best threshold of each. We still have a lot of work to do, so we have to complete our experience with baseline spam classification models, and also with respect to n-grams, we have to experiment with feature selection and hashing techniques. And after we are satisfied that we have found the best baseline that we could find, we want to put it in production and make sure that training and classification work smoothly in production with that baseline. Afterwards, we'll experiment with more advanced deep learning techniques and put that again in production when we have a good model. And lastly, we want to experiment with multi-class classification, so different kinds of gray mail. And that concludes my talk. Thank you for your attention.